What's up, guys? This is going to be a video explaining the first 13 experiments of this basic electronics experiments model PK101 kit. Experiment 1 follows the following circuit. It includes a 9-volt battery, which then leads to a switch connected to a 10k ohm resistor, which then connects to the diode, and then having a wire connecting back to ground. The result of this circuit is the diode turning on as I press the button on the switch. Experiment 2 is the following circuit. It also includes a 9-volt battery connected to a switch. The only difference between this one and experiment 1 is that this one contains a variable resistor right here located in the middle, which acts as brightness control. As I move the resistor to the right, it increases the resistance, therefore leading the LED to be dim. And as I decrease it to the left, it decreases the resistance, allowing the diode to become brighter. Experiment 3 contains 2 resistors in series. Therefore, the total resistance is the sum of the two resistances of the two resistors. This experiment gives the same result, allowing the LED to turn on as I press the button on the switch. Experiment 4 is the following circuit. It contains the same resistors as experiment 3, but instead of the resistors being in series, the resistors are now in parallel. Since they're in parallel, the total resistance changes, as instead of the sum of the two resistances, the total resistance is by the following formula. 1 over the total resistance is equal to 1 over R1, which is the resistance of resistor 1, plus 1 over R2, the resistance of the second resistor. Therefore, since the resistance is less, it allows the LED to be brighter. Experiment 5 contains 2 diodes denoted as left and right, and both of them have different resistors according to its path. Therefore, the path with the least resistance will lead to the diode being brighter. In this case, it is the right diode, which can be seen to be brighter as I press the button on the switch. Experiment 6 combines the previous elements learned in the past experiments and combines them into one. Therefore, it includes the variable resistor, the 2 resistors in series, the 2 diodes, and once again, the switch. The purpose of this experiment is to show how current flows through different paths of the circuit. Therefore, the variable resistor right now is turned all the way to the left, which means that its resistance is at 0. Therefore, more current will be passing through the 3.3 ohm resistor. Therefore, the light from the left will be brighter. As I move the current, the resistor dial to the right, it increases the resistance of the 50k ohm variable resistor, therefore allowing the diode to the right to also light up. And both light up evenly as the current is distributed evenly between 2 paths due to the increased resistance of the variable resistor. Experiment 7 is the water detector, and it follows this following circuit. Currently, right now, the diode is turned off as the circuit is open, as the red wire is not submerged in the water. Yet, when both of the wires are submerged in the water, the diode will turn on due to the conductivity of water. So this blue cup contains currently just regular tap water, and as I submerge this red wire, the diode will turn on. Very dim light. Yet, once I get a cup of salt water, the LED will be brighter. So this cup contains salt water, and this is because the water has a lower electrical resistance when the salt is dissolved into it, therefore leading to the LED being brighter. Experiment 8 introduces a capacitor. The capacitor is this device located right here in the middle. As I press the switch, the capacitor is charging, therefore it leaves the light to turn on gradually. And as I let go, the capacitor discharges, therefore LED turns off. Experiment 9 is similar to experiment 8, yet instead of just one capacitor, now we have two. One of 100 millifarads, the other of 10 millifarads. So here's the circuit. And what this does is that the capacitor with the least capacitance takes over the circuit, and therefore the LED takes less time to charge, or the capacitor takes less time to charge, leading the LED to light up faster. So as I press the button, it lights up faster than before, and also it discharges faster. Experiment 10 now places the capacitors in parallel, and capacitors in parallel add up similarly to resistors in series. So you just add up the capacitance. So in this case, the 100 millifarads and the 10 millifarads capacitor will add up to make a total resistance of 110 millifarads, and this leads the overall time of the capacitor to charge and discharge to increase. Therefore, the LED will take more time to light up, and as I release it, it also takes time to get back to its initial state. Experiment 11, called Make Your Own Battery. It includes a loose wire in the middle of the circuit. Also, the positive side of the battery is disconnected from the breadboard, and there is also a resistor which only one terminal is connected onto the breadboard. So what this experiment states is that as I touch the red wire with the loose wire, it will charge up the capacitor, and then as I touch the green wire to the resistor, that charged capacitor will provide the current in order for the LED to light up. Experiment 12 contains both a diode and a light emitting diode. So the purpose of this is to show that diodes are just one-way devices. The current can just flow in one way. So as I press the button, the LED will light up. Yet, if I switch the wires in the diode and try to replicate the same experiment, the LED will not light up. As the diode is similar to a water valve, it is only a one-way entry. Therefore, right now, there's no current flowing through that diode, which leads to the LED not turning on. The last experiment, experiment 13, contains several loose wires. There's a loose wire located in the negative side of the battery, and the inside of the circuit, and also the positive side of the battery is not connected onto the breadboard. So the purpose of this is to show that as I touch the positive side of the battery to the loose wire, the diode will light up as the capacitor reaches its full capacitance. Then, as I touch the two green wires, the left diode should now light up as the capacitor will be discharging.